Okay, we're gonna be doing the conversion into esters. Basically, we're gonna be making this lactone. It's basically it's like an epoxide, but for like esters. This is how it's gonna start. We're gonna do a symmetrical ketone. So hopefully you can see that. Okay, bet. Um, so you're gonna treat it with we're in acidic condition. So this is if you read the notes, it's called like triplic acid. It's hella like acidic. It's pKa is equal the pKa is equal to -14. So it's really acidic. But we're also using MCPBA. Okay, but first off, like I don't even know where it comes from, but since we're in acidic conditions, I assume like we have hydronium. So the first step, we have hydronium. So it's pretty obvious what's gonna happen. We're gonna activate the carbonyl. Oxygen already wants electrons, right? Oxygen loves electrons. He's electronegative. He's more electronegative than carbon. And so if we put a charge on him, he's gonna want it even more. Okay, so the first step is acid base. So if you put a charge on oxygen, it's going to be a delocalized charge, so we could show the resonance structure. I got to do this quickly. It's going to take a while. Yeah, so he's going to have a charge. Push electrons, so there's going to be double bond right here. Push electrons right here. So, okay, this should be good. We're going to have a charge on the carbon now. So, who do you think is going to attack the carbon? Um, Really, now we're going to use MCPBA. So this is how you draw MCPBA. It's like a H. It's two. It's basically a weak. It's weak. It's like a bond with two O's, and then maybe I'll draw it this way. Yep, this looks like it. And then they have this like aromatic crap, and then you have Cl. Let me draw Cl like this. Okay, so right here, um, it's important to know who's gonna be attacking, right? Because you have like this oxygen, you have this oxygen, and you have this one. Okay, so this one is sp. I'm gonna use a different. So this is gonna be sp2, sp3, and sp3. Sp3 is farther from the positively charged nucleus, whatever that means actually. But I just know that just to remember, sp3 is more basic. So then you could know who's attacking. I'm assuming this one attacks because it's the furthest out. So yeah, so this one's gonna be attacking. Alright, so oxygen is gonna attack that right here, that carbocation. So just make sure you draw that. So right here we're gonna have OH, and then we're gonna have oxygen, and then we're gonna have the structure right here. Bam. And then Cl. Okay, so now the thing is, so if you drew it correctly, right? So let's say I drew it correctly here. Oxygen has two lone pairs. So um if he bonded right there, he has an H. So make sure you draw his H, right? So that means he has a positive charge. If you draw your H's, you won't make the stupid mistake. So now he's an oxonium ion. This is not good. So obviously we need to deprotonate him. So we're gonna deprotonate him with what we have, right? So we formed water right here. So I mean, obviously water's gonna come in. So just make sure you draw like water. We made water, right? So water's gonna come deprotonate him. Bond in the middle, and then this is gonna go straight onto the oxygen. Okay, so if we have this, and then boom, boom, and then see. Okay, now what we're gonna since we're all neutral, right? We're in a neutral thing, but what we have is we have this weak OO bond. We're gonna have to get rid of it. So, and since we're in acidic conditions, when we make the leaving group, we're gonna need the leaving group to be neutral. So we need this to be positively charged right now. So we're gonna have to protonate him. So we're gonna do acid base with the hydronium, and we're gonna do acid base with him. So we're gonna make him positive charge because when he leaves or whatever, he's gonna be able to, like, he's gonna be able to be neutral. Okay, now that we did that, is that correct? Yeah, that's correct. Okay, bam. Let me just draw this correctly. That looks fine. Um, so now we're gonna do this thing where it's like we're gonna take this bond. It's gonna take this oxygen. This is gonna go straight onto this oxygen, and this is gonna go. Oh, I think we have to do resonance first, because this Loki looks like a resonance structure. So yeah, we're gonna do resonance first. That looks a little bit weird. Yeah, we're gonna do some resonance. I think. Honestly, I didn't even check. Okay. This just makes sense to do resonance. We're forming a delocalized charge. So just push electrons onto that. Okay. Yeah, so now we're gonna have that little thing where this attacks this attack. Okay, so this is gonna take the O. It's gonna break the OO bond, and we're gonna make a strong CO bond. This is gonna go onto here. Oh shoot. What was it? It was gonna go. I know it's gonna go onto here, and this is gonna go onto here, and then this is gonna go onto here. So maybe this one is the correct thing. Yeah, I don't even think we needed to make a resonance structure. Yeah, I'm sorry. Hey, no resonance structure. So this is gonna go straight onto here. Yeah, so that goes there, and then you make your compound, right? So this is gonna be the thing. So we have O. Since we made a new bond, so this is gonna be new, right? So I don't know how to actually draw it correctly. I'm gonna just try my best. It's gonna go like this, and then this is gonna go here. No. I should actually. Okay. It's gonna go. It's gonna go there. So low key, we could do this. Yeah, it's gonna work. Okay. So O right here, and then yeah, this looks geometrically correct. I won't lose points for this. Okay, but since now we formed that, we got rid of like his octet, right? So he's gonna have a positive charge right here. And then now we form this neutral compound, right? I think it's called, I think I wrote in my notes, it's called metachloric benzoic acid. So, just draw it out because, we formed it. So then this is going to go onto that, right? So, um, yeah. So it's going to go here. We're going to have OH. And then, yeah, the resonance structure was like not important because it didn't matter. Um, yeah, 3 arrows. We don't need to do resonance in the last step. I remember that. Okay, so we're basically done. We basically got our compound, but we have a resonance structure right here. So we have a delocalized charge. Let me put that actually more near. It's right here. So then just push electrons toward it because we're going to want to make our final product, right? So it's going to go here. And so now, imagine like I'm drawing like a really big arrow. Forget about this guy. Like he's in his own world. Maybe put him in like pink or something. He's really not, like, forget about him. And then, double bond right here, and then oxygen's gonna have the charge, and then who do you think is gonna deprotonate him? Our friend water, okay? So water's gonna come deprotonate him, and then we'll be done. And then obviously we're gonna have to regenerate the catalyst. So when you write your answer, yo, this is the final answer. We got this, and then just regenerate the OH. All right, regenerate the OH, and then we should be good. Driving force for this is that we're breaking the weak OO bond and we're replacing it with a strong CO bond. Um, these notes obviously are not in order. There's obviously not 9 steps. I just put a bunch of notes in it, honestly. Yeah, we form lactone.